Massinissa is going to talk about 5G virtualization. And if I got it right, by the end of the day, we will be able to deploy a 5G core in our labs. So
Yes.
thank you, Massinissa, for being here. And the floor is yours.
Thank you for the invitation. So hello, everyone. Thank you for attending this presentation. I am Massinissa Abba, optimization researcher at Davidson Consulting. I am working with Telecom Sud Paris on the European project IDF2, so in collaboration with Telecom Sud Paris. IDF2N started on September 2020. On this project, we use classical modeling techniques and machine learning techniques to optimize the network slicing in 5G networks. So I work with Badij Weber, Castle, Andrea Araldo, and Adil and DSR from Telecom Sud Paris. So I represent Davidson Consulting for this LabCom IDF2. In this presentation, first I'm going to show you the emulation platform we're using in IDF2Zen to test our solutions. In the end of this presentation, I hope that you will be able to you will know all the steps to deploy a 5G network, so a core network and a radio part. So it will be like a real core network. So you can have like a real 5G network in your on your machine. And then I will talk about our Kubernetes scheduler. So our platform consists of an OpenAirInterface core network, which represents 3GPP 5G standalone core network implementation. The core network consists of 8 pods, each containing virtualized network functions. You can connect this core network to a radio, like you can connect it to small antenna like USRP, and create a 5G network which you can use with real phones. So however, if you want to make large emulations, you will need a lot of USRPs and a lot of phones, which can be a little bit expensive and hard to configure. So this is why I'm using UERANSIM, which is an open source 5G RAN simulator, which simulates user equipment and radio parts. So in this part, we will have an OpenAirInterface core network, which is also open source from OpenAirInterface. From Oricom in the south of France, so they propose a complete implementation of core network. It's release 16 from 3GPP. And so the core network will be connected to internet. And for the radio part, for the G-Node B and user equipment, we are going to use UERANSIM, which is an open source tool to simulate G-Node B and user equipment. So for the core network, we will have like a real core network, and for the radio part, we will have a simulation. Okay. So all the links or all the steps you need to deploy the 5G network and the radio part are available on this link. So we are going to do this together. So step by step, I will show you how to deploy a 5G network on your machine. Okay. So I'm used to speak very fast. So if you have any questions, so you can stop me, and I'm going to repeat and explain. Okay. So let's open this link. And so in this link, you will find all the steps and all the details, and you will find more details about the core network. So the explanation of each part of the core network. Okay. And you will also have you will also get links to go if you want to open an interface web page to see more details about the core network they propose. Okay. And in the beginning, you have some line commands to install Docker and Kubernetes. And then you have all the steps to build your Kubernetes cluster on your lab. Okay. So let's do this together. So now I'm going to create cluster on my machine. So I just copy paste this link, and after a few seconds, I will have master node on my machine. Okay. So the master node is the control plane of the cluster of Kubernetes cluster. So you have all the steps to configure and build the Kubernetes cluster, because we are going to deploy so our 5G network on the Kubernetes cluster. Okay. So that's a little. So sometimes it takes like 30 seconds. Good. So I have just to use three links provided by this. Okay, now so I have master node on my machine. Now I just need to initialize the network inside my Kubernetes cluster. For this, I have to configure the container network interface. For this tutorial, I'm using Flannel CNI, so you will find all the details about this if you want. Okay, so now I just run this command to see if everything is fine. So as you can see, I have my master node, which is ready. Okay. So the goal of Kubernetes is to be able to create like a cluster of several machines. Okay. So if you want to create a cluster of several machines, you just need to run this command on other machines. Okay. So for example, I have this my machine, and I have two or three other machines. Sharing the same network, so I just have to use this link to use this link on each machine. So those machines will join my master node, and then so I will have like cluster of several machines. Okay. For this tutorial, I'm going to use only one machine. So it's the same thing, but if you want on your lab, you can use a lot of machines to, if you want to create a lot of, for example, a lot of 5G networks. Okay. So I have a master node. By default in Kubernetes, you cannot deploy workload on master node. So it's tainted by default. So if you want to use to deploy pods and workload on your master node, you need to follow those steps. So we'll just describe your pod, your node. So let's do this together. So you go to this line. So it's explained on the tutorial, and you can see that it's tainted. So you have to remove this taint to be able to schedule pods on it. Okay. So just using this line command, you will be able to untaint your pod. Okay. So just add the minus at the end, and then as you can see, it's untainted. So you can deploy now pods and workload on it. Do you have any questions for the moment? Okay, no questions. So now we have
I
already
think
mastered.
Massinissa,
Yes.
maybe the when you use the command line, I think it's too
Yes.
small. So maybe next time you can zoom a
Yes.
bit. Yeah, just that. Yeah.
Yes. Is it good like this?
If it's a bit more, it's better.
Okay. Is it
Yeah,
good
now I think it's
like
better. Yeah, yeah, yeah. Now it's good. Yeah.
sorry. So now we have like a ready master. So we are going to deploy now the core network on it. So as I said, so I'm using only one machine. So I'm going to do everything on the master node. But on your lab, yes, you can add worker node and then like use a lot of machines. Okay, using Kubernetes. So now for to deploy core network, so again you have to install some tools. So I provided the links you need to do it. So I already down this on my machine, so no need to do the installation. I just have to deploy the Maltus CNI because it's needed for the core network. Okay. So let's do this. So I already like cloned the repository and Maltus and everything. So I have everything installed on my machine. But for you, you have just to follow the steps, and it's really you can see that it's really easy to do it. Okay. So this is a step to deploy Maltus. And now I'm going to create a namespace, name it OIE. So this is where I am going to deploy our call network, okay? So now I have my namespace named OIE created. So then you clone this repo to see the files, and then using only two lines, you will be able to deploy your call network on your machine. So let's do this together. Just I'm going to run a line to see the pods already I have on my machine. So using this line, you will get all the pods deployed on your cluster. So for the time being, I have only the pods related to Kubernetes system. So no pods related to the core network. But now let's deploy our core network. Yeah, so here in this folder, so following these steps, you just need to run two lines here to deploy your core network. Okay. So now the core network is we started deploying the core network. So we have 8 pods in total. So first it will deploy the first 2 pods because we need them to respect some order for the configuration of the core network. So this is deployment of the core network. Now we are deploying 4 pods, and here you have the status. So they are running.
I have a question.
Yes.
So there are these 8 pods. Where are they specified? What is
Yes.
the configuration file? And I guess you call this configuration file in your command, right? Can you
Yes.
explain that part?
So using Toolham is it's very easy and very automatic to deploy it. So we are not going to do it like one by one. So this is very good. And if you want to configure the pod, so you have manifest files of each pod on those folders. So you just go to OA5Gcon, and then you can pod by pod you can open the manifest file. For example, for this one, you have the value here, and you can make some modifications. For example, you can make modifications on the resources you need by pod. For example, here we have like the request. So we have 2 containers inside the pod IMF. So you can just modify those informations to modify the resources reservation, okay, for each pod. So
Okay.
for each pod, you have a manifest file here. So after modifying, you just have to run the first command to update the configuration, and then run this command again to deploy your core network. Okay.
Okay.
So as you can see, the core network is deployed. So I have now a 5G core network deployed on my machine. Okay. So you have all the steps here, as you can see. So only with 2 commands, I was able to create core network on my machine. So now let's go to UERANSIM. Okay. So now we are going to connect the G-Node B to our core network. So for this, you just go to the repository, to the official repository of UERANSIM, to clone it like this, and then follow the steps to install it. It takes like 10 minutes to install it. It's very easy. You just have to configure the UERANSIM with your core network, so because it will depend on some details, but you will not need like a lot of time, because I created script to do this in automatic way. Okay, so no need to go on details for this. So you just have to run this script, and it will do it. So as you can see, like, you will have this message if your code is okay. And now you have UERANSIM G-Node B configured. So you are going just to connect the G-Node B. Okay, so now the configuration is good. Let's do it in the same terminal. Okay. Yes, I have to zoom. So now I configured my UERANSIM. So now I'm going to run this command. Yes, tell me. Okay.
Yeah. Okay. No. I will ask later. Maybe you will answer. Yeah, I will ask
Okay.
later.
Okay. So we just need to open another terminal and run the following command to run the UERANSIM G-Node B. Okay. Okay. Yes, I know why. Okay, so I'm going to this folder, and then I have just to run this command to connect the G-Node B. So now I have core network from OpenInterface, and I have a G-Node B from UERANSIM connected to my core network. So now we can say that we have whole 5G network deployed on our machine. So this is core network. So the radio G-Node B is connected to our core network.
And
And
here is
now,
my trivial question. So,
yes,
how how can the G-Node B know where to connect? Where is the core? So do you have to specify an IP address, a port, or
yes,
something? And what is among the 8 pods? Is the G-Node B connected to the IP address of one of those 8 pods?
yes. So everything is on this link. So you just have to give the link of IMF pod and the pod. So just have so here using this script, update UERANSIM, it will modify directly those informations, and this one too. So it will give the IP address of IMF. So the IP address of IMF, you can get it from here. To do this, you just have to add this, and as you can see, the IMF is here, so the IP address is this one. So the script will modify directly this this value, okay? So we'll not modify it by hand. So the script will do it directly, and then it will put the IP address here, and here it will put the IP address of your machine. So if you deploy the call network in another machine, so you will need like the IP address of this machine, and that's it. So
Okay, thank you.
here the IP address of the
Yeah.
machine where the call network is deployed, and here the AMF IP address, and then so the script will modify this value, and then it will directly copy it and paste it on here. So as you can see here, the scripts did everything, so no need to do it by hand. So here we have the IP address of the ANF, you can see. So it's already copied, and here's the IP address of your machine, okay? And that's it. So this is how you add the GNODB to your core network. You're using only one line command on this tutorial.
And can you add more than one GNODB?
Yes, you can add more than one GNODB. So I didn't do this in on the script, but yes, you are able to. You can add more than one GNODB to your core network.
And you redo the same process. You run the same script and.
Yeah, to be honest, I don't remember how I did it, but I think it's not really complicated. Yes, I think you just follow the same steps, but you just need to modify something maybe to be able to add second GNODB.
Okay.
But it should not be complicated to add it. Yes, you can add this. So once I connected the GNODB to my core network, let's now connect the user equipments to it. Okay, so now we have a 5G network. We want to use it, so using user equipment. So again, we will use UERANSIM to emulate or to simulate user equipment. So just using this line, so you will be able to add user equipment. So I think on this tutorial it's limited to 100, but you can add more just by modifying one file, and the file you have to modify is on MySQL database, and just go to this folder, and then you will find this file. So just open it, and as you can see, there's some user equipment added to the database. But if you want more, so you just have to modify these files, and you add as you want the number of. I think I have 150 on this. No, I have only 50 there. So from 100 to 151. So we have 50 user equipments on this database, but you can add more. Okay. So now I have connected the GNODB. So let's connect the user equipment. So we just need this line command. Okay. So as you can see, I have one PDU session created for my user equipments, named UERANSIM1. So let's go to the GNODB, and even the GNODB. So as you can see, it's updated the information. So it was the user equipment was detected, and then it will create a PDU session for this user equipment. Okay. So I can add more. Let's add a second one. So again, our GNODB will create PDU session for second user equipment. Okay. So you can create as many user equipment as you want. And now you can, using this link, this command, you can generate some traffic for the for your user equipment. So let's do this for the first user equipment they created. So if you want to generate the traffic for the second one, you have to modify this value, okay? So just a sample ping, and then you can, for 3 seconds, you can increase this.
So
Sorry,
this
I have a question about
Yes.
the user equipment. So you generate them, but you're also generating a random placement and the radio interface and the radio propagation and all of this?
Yes, UERANSIM is doing all this. I don't know if I can give more details about the placement of the user equipments. If you mean like you can place it like on a different distance from the 0 B. I don't know if you can you can do this using UERANSIM.
Okay.
Yes, I'm not sure you can do this with UERANSIM. Yes.
do you know if the user is moving?
No, I'm not sure that the user is moving. This is, yeah, this is. But maybe if you want to do some good simulations, you have to change this. So here I'm doing the ping to Google. But if you want like at least to change, the amount of traffic, maybe you can change this value. But moving the user equipments, no, I didn't find a way to do this using ARNSIM.
Okay.
But you tried, then you didn't find.
Yes, I tried this, even with Akim, so it was a little complicated to configure. So maybe someone else, if he spends more time on it, I think he will be able to do this. But for me, no, I was not able to.
So in the documentation of UERANSIM, do they say that it is possible to use some movement model, etc.?
I don't remember. I read this on.
Okay.
Let's.
For the moment, you have a user equipment that is static, but I guess
Yeah,
it's possible to let it move. I guess.
yes, I think it's static, so you have to.
So I imagine you don't have a lot of room to change the radio conditions.
Yes, I didn't find a way to do this. Frankly,
Yeah, maybe this is not the right tool for that, simply.
So yes, we generate the traffic for the user equipments one, but you can do it for the user equipments two. So just modify this value. So instead of 0 here, you put just 1, and then you generate the traffic for the second one. Okay. So now, as you can see, like we deployed the 5G network, so the radio part, the con network, and we attached some user equipment on it, and we were able to generate some traffic. So even if the user equipments are not moving, but at least you have like some traffic for the user equipment. So now we are going to set up a Prometheus monitoring tool and Grafana dashboard. So using this, you will be able to monitor the resources consumption of your 5G network. So you see like memory consumption and CPU consumption. Okay, so it's very easy. You can just follow the steps, and then you will be able to do this. Okay, let's do this together. So just go to Prometheus folder and follow the steps. So I was able to do it with script, but for this I wanted to put some details to see what exactly you are doing when you use these lines. So for this tutorial, I'm not going to talk about it, but you can read the text I provided here to see how it works. Okay, so now I deployed Prometheus. as you can see here. So following this step, so just configuration, so it's not very important. So this is why I'm going fast on it. So just to show you that following the commands, you will be able to deploy Grafana dashboard on your machine. Okay, so now I deployed Prometheus and Grafana on my cluster. So I just need to use this link to access to Grafana dashboard. Okay, so let's run this command. We just have to modify the name of the Grafana pod for this. Let's go here and get the Grafana name. This is the Grafana name pod. So we just modify this and put the name of Grafana. And that's it. And now we will be able to access to Grafana dashboard following this link. Okay, so let's open it. So if you want to modify the passwords, okay. Okay, so all the steps are here. Okay, so you just need to access to the to Grafana website from here, and then you just need to upload the dashboard JSON file. So I provided on the tutorial. So just click on this and then import the dashboard, and then you will find the dashboard JSON file on this folder. Okay, and then click on import, and here you have a complete dashboard where you can see the memory usage in real time of the whole namespace. And if you want, you can go to see each pod. If you want to see the data of each pod, so you can just click here, and then you can see even if you want to see information about each container. Okay. So here where you can see memory usage of your core network. So we're not using a lot of memory, as you can see, but we requested a lot. So we requested like 2.75 gigabyte memory. So we can modify this file on the manifest. Okay, so here like I put information here, like for example we requested for a SNF file 0.4 giga for the memory, but you can for the CPU, but you can modify this value. Okay, just have to update. And you can see CPU usage too. You can see the CPU request. So we are requesting a lot. Okay, we are requesting like for 30% of the CPU resources I have on my machine, but we are using only 1.3. Okay, and you can see also some graphs here, and to see in real time the memory usage, so it's quite stable, and you can modify the value here to see like in 1 hour in 2 days, so you can like or in 5 minutes. So as you want, you can modify this value. So here you can have a graph of memory usage and CPU usage per namespace. So here we're dealing with open OIE namespace, so just to monitor our core network. Okay, and you can see this also by pod. Okay, so we have the CPU usage by pod and the memory usage by pod. This is so the dashboard, Grafana dashboard, to see how many resources you are consuming with your core network. Okay, So you will find all the steps here, and you can use EPS3 to generate more traffic if you want. So instead of using the line commands I provided here, okay. So instead of using ping, you can use EPS3. So again, I provided all the command lines you need to do this. So let's use EPS3 now to generate more traffic. Okay. So I already have.
Can you also zoom more the web pages that you brought?
Yes. Yes. Okay, so for the GNLP. So let's now we are going to generate traffic using EPS3. Okay, so just run this command. I'm going to close the user equipment here. So GNLP, I will keep it. I need it, but no need for the user equipment. Even here, I don't need it. For this one, I have to keep it. Okay. Okay. Now I'm going just to run this command to deploy APS3 on my cluster. Okay, I will need it to generate some traffic, so it's created. So here APS3 is running, and then I'm going to connect APS3, so the pod of APS3 to some user equipment. Okay, so for this I created a script that you can use to generate some traffic using EPS3, and then you can modify the number of user equipments and also the seconds. So it depends on how you want to do some simulations. Okay, so let's try this. So you just need to run this command, and for this I have to do it on this folder. Okay, and now you just run this command. So for example, I'm going to generate the traffic for 10 user equipments and for 20 seconds. Okay. So as you can see, it will add like 10 user equipments to my Gnode B, and it will generate some traffic using APS3. Okay. So for 20 seconds. So as you can see, it's very easy to do some simulations if you want. And finally, I created another script just to see the impact of the traffic on the CPU and the memory consumption. So I created this script. So just run this script here. The file is provided here. And you will be able to generate some traffic for 5, 10 until 50 user equipments, and for 6 minutes each. Okay, so I'm not going to run this script now, otherwise it will take like 10 times 6 minutes, like 1 hour. Okay, but I'm going to show you just the result of this simulation. So as you can see here, by increasing the number of user equipment, so we are going to consume more CPU. And for the memory usage, you can see that we are the memory consumption is increasing too. So this is normal. So if you have more user equipment on your core network, so the core network will work more. So we will do like more things, and it will consume more CPU and more memory. So this is what you will get if you run this script. Okay, so it will generate the traffic for 5, 10, 15 until 50 user equipments during 6 minutes each. and using Ether3. Okay. So this is the end of the first part of the presentation. So if you have any questions, don't hesitate before going to the second part, where we are going to talk about our Kubernetes scheduler. Okay. So no questions for this part.
No, it doesn't. So it's clear what you managed to do here. So basically, you managed to monitor the resource consumption of the whole network.
Yes.
And is there a way to monitor other quantities using the same setup?
Quantity, for example, energy.
Well, I suppose this setup is not good for looking at the radio part too in detail, but I suppose you could try and look to monitor what happens inside the core network. Maybe you didn't try that because it's not something interesting for you, but
Yeah, frankly, I didn't do this for the radio part, so only for the core network. But yeah, sure, you can modify the dashboard as you want. So you just go to the metric of each part. So just click here on edit, and you can see that it's not really complicated to modify. So you can just see the metrics here, and you can modify them. Okay. Maybe you will need some time to read the configured to read how to say this, to read about dashboard, Grafana dashboard, for documentation. Okay, so if you go to see the documentation, then you will be able to modify this metrics command.
okay.
And you can add for the energy part, we used the watt meter. And I also used Scaphandre, but for me it was not very efficient Scaphandre. Maybe I used also Kepler, if I remember. So Kepler and Scaphandre, for me, I didn't find them very efficient for my use case. So for the software tools, for me, I don't suggest to use them for this tutorial. So for me, it was not working fine. Okay, so Scaffold and Kepler, for me it was not working fine. But I used the watt meter. So watt meter, you can monitor the energy consumption of the whole machine. So yeah, it's better. So
Okay, thank you.
welcome. So if you have no questions, so let's go to the second part. Second part, where I'm going to talk about our Kubernetes scheduler. So as you can see, we are deploying like core network of 8 pods, and the default orchestrator or the default scheduler of Kubernetes is doing this like pod by pod and without taking into account the whole core network. So when it deploys the first pod, for example, MySQL, it will not take the information about the other pods. So this is why we wanted to create another orchestrator which is able to take all the informations of all the pods together when it takes the decisions about the affectation of the pod to the node. Okay. On this tutorial, as you can see, we are using only one machine, so we don't have a problem of scheduling or orchestration because we are going to deploy the whole core network on only one machine. But if you have multiple nodes, and you want to deploy like a lot of applications and for example, a lot of 5G networks, a lot of independent 5G networks for different users. So you will need to do it in an efficient way if you want to use less machine. Otherwise, you will not do this in efficient way. So you will use like more than a machine you need, because it was not very efficient the way you did the deployment. So this is why we created a new scheduler. For example, let's take this example. Okay, for example, you have like a slice or an application or which consists of 4 pods, and you have 2 physical nodes. Okay, so the capacity of each node is 8 cores. I'm talking about the CPU, and the CPU request of each pod, so from 1 to 4, is 2 cores for the first 2 pods, and 5 for the 2 other pods. Okay. So as you can see, if you want to use default scheduler of Kubernetes, so if you will deploy in this order the pods, so Kubernetes will not see the information of pod 3 and pod 2 and 3 and 4 when it will deploy the pod number 1. So what Kubernetes scheduler will do deploying this application, so it will deploy the pod number 1 on this machine, because you need only 2 cores for this pod. So since you have this worker node which has 8 cores, so you are going to deploy pod 1 here. Okay, and then Kubernetes will deploy second. After deploying the first one, it will go to deploy the second one. And here again, you need like 2 cores, and here you have like 6 cores left, because you already have pod 1 deployed on this machine. So it will deploy the pod number 2 on the worker node 1, in order to not use the worker node 2. Okay. Maybe so you can find a lot of examples. Maybe it will do another scenario, but you will see, you will see that no matter the way the Kubernetes scheduler Kubernetes will do this, you will always find like an example where you will do this in not an efficient way, because as you can see here, the pod number 3, you need only 5 cores, so you will deploy it on this node. Okay, so here I have 4 cores, and here I have 3 cores left. Okay, because I consumed like 5 cores using pod 3. So now I want to deploy the pod number 4, which need 5 cores. So it's impossible to do it here, because here we have only 4 cores left, and here we have only 3. So as you can see, I'm not able to deploy the whole application. So we are going to remove the slice of the application from our cluster. But if I had all the information at the same time, I was able to take more efficient decision. For example, so if I can deploy the pod number 1 here, and the pod number 4 here, and 3 here, and 2 here, so I am able to deploy the whole application on my cluster, because here I have like 2 core for the pod 1 and 5 for the pod 4, and since I have 8 cores here, so it's good. And say the same for pod 3, so I need only 5 cores, and here I need only 2 cores. So since I have 8 cores on this machine, so I'm able to deploy the 2 pods here. So finally I deployed 4 pods on my cluster using only 2 machines. For here I have to use another worker node to be able to deploy my application. Okay, while I need only 2 machines to deploy it. So the set pod, so we name it our orchestrator set pod schedule, because it takes into account a set of pod together to deploy the whole application on the cluster. Okay, so inside the orchestrator, so we use a genetic algorithm, and the orchestrator will wait until it will receive all the information about all the pods, and then it will will use this information using the genetic algorithm to see if there is a solution to deploy all the pods on the cluster. And if solution exists. So here it will start deploying pod by pod on the cluster. Otherwise, it will refuse the application. So instead of Kubernetes standard scheduler, as you can see, it will deploy like the first 3 pods, and then it will figure out that it's not possible to deploy the last one, and then it will remove the 3 pods already deployed. So waste of time and waste of energy, while in our orchestrator, so it will decide directly in the beginning if it's possible to deploy the whole application or not, and then it will start deploying the pod. So you can find the orchestrator here. Just tell me if you have questions before going to the link. Okay, so here you find the orchestrator, so you can use it, and I provided 2 examples where you can use it. So as you can see, it's very easy. I will show you that it's very easy to use it. Just you need to clone this repo. Okay. I'm going to do it here. I don't remember if I did it or not. No. Okay, so I just need to clone this. Okay. And
We don't see
yeah,
your command line. Okay.
yeah, sorry.
No, okay. Sorry. I had the lag. Sorry. You can ignore my.
So yes, I just need to clone this repo and going to deploy my new scheduler on my machine. Okay. So just using this line, you have a new orchestrator on your machine. I'm going to stop all those. We don't need them. We don't need them anymore. I'm just going to free the namespace here because. So I'm going to remove the call network. So just to remove the OIE namespace using this command. Okay. Delete namespace. Okay. So just I'm going to delete the OI namespace, and you will see that yes, I will free these resources. I need them. Okay. So now I deployed my new orchestrator. You can see it here, set pod scheduler. So the orchestrator is running, and even the Kubernetes standard orchestrator is here, and the set pod scheduler is here. Okay, so you can use a lot of orchestrator on your machine. You just need to specify which orchestrator to use when you deploy your pods. Okay, and this you can find it on this tutorial, and you can find that just to specify the schedule name of the manifest of the pod. So I provided 2 examples here. So let's go to example number 1. So I want to deploy an application which consists of 2 pods. So let's open the files. Oh, I'm going to close all those. Okay, we don't need them. So here I have an application of pod 1 and pod 2. So I have just to specify the name of the orchestrator in order to use set pod orchestrator, and to add some labels to the definition of the manifest of the pod. Okay, so this is the name of the pod, test pod 1, and just need to add the ID. So this for this pod the ID is 1, and for the second one the ID is 2, and just need to specify application differentiator. So if you have like a lot of applications, you have to modify this value. So for this application is 1, and for the another application it may be another number. Okay, and you have to specify the number of pods. So for this example we have only 2 pods, okay? And you can add the time limit. So the time limit, so it will use it by the genetic algorithm to limit the time it will use to find the solution, okay? So if you put 10 seconds, so the genetic algorithm, if after 10 seconds it doesn't find the solution, so it will just stop and it will tell you that I didn't find the solution, okay? So the container is just did this. So just for example, okay, so we are using the same container for the 2 pods. So let's deploy this application together. It consists of 2 pods. Okay, so in the cluster, you will in the tutorial you will find how to create a cluster using kind. So if you want to use just kind to deploy a cluster instead of kube ADM, and you deploy your set pod orchestrator. So we already did this. And now let's deploy the application. Okay, we are going to deploy the first pod using this line command. So as you can see, I created the first pod. Let's go if it was deployed or not. As you can see here, it's in pending status. So so Kubernetes will not deploy it because our orchestrator didn't receive the whole information about all the pods. Okay, so it is waiting for the second pod. So let's give him the information about the second pod. So just we run this command, and now as you can see, it created the first one and then it created the second one. And if you want to see the logs of all this, you just run this command, okay? And you will go to get the std log file, and you can see that the genetic algorithm found the solution, okay? And then it will deploy it on your cluster. So as you can see, we were able to deploy our application using this orchestrator, and let's use it to deploy the call network. Okay, so you have the steps to install Helm and everything, and we will going to do the same steps than before. And the same steps I used here. So I'm going to create a namespace. Okay. So I'm going to create namespace IE, whatever. I'm going to deploy the call network using my orchestrator. And then I will run the same command to deploy it. So just go, let's go to see the details of the manifest of file here. So let's see, for example, UDR pod. And as you can see, I had to put this information here, okay? So the name of the set pod scheduler here, and the ID, this is the third pod, and application differentiator. So here it's 2, so it's different from the first application, it was 1. And the number of pods here is 8 for the call network, okay? So we'll just use those commands to deploy the core network using our orchestrator, okay? So we have to update the configuration because we did this modification. And then just using this line, I'm going to deploy the core network. As you can see, it is pending. So because the orchestrator so received all the informations, and then it found that it's possible to deploy the call network, okay? So as you can see, we started the deployment of application number 2, and then we found the solution, and then we start the set pod scheduler. We will start deploying the application pod by pod. So let's wait until the end, okay? So it will do it pod by pod. If you want, let's modify the manifest of one pod. Let's increase like the CPU in order to not be able to deploy it on my machine. Okay, let's say we are going to put like to ask for 8 cores, which is impossible on my machine. I have only 8. So if we do it like this, so we save the file. Okay, and as you can see here, we have the limit, and here we have the request. So what is the difference? So the request is the amount of resources which will be reserved to this pod by Kubernetes. Okay, so it's impossible to use these resources by another pod. So it will be reserved for this pod. So for the CPU, we are going to request for 8 cores for this pod, for the UDL pod. Okay, so Kubernetes will see if I have this amount of CPU available on my machine. If it's not the case, it will not deploy the pod. Okay, and here we have the limit. So the limit is you can put it like 16, for example. So it may be different from the request, but it have to be like higher. Okay, so equal or higher than the request. So the goal of the limit is if you want to use more than 8 cores, so Kubernetes will allow you to use more, but not more than 16 core in this example. Okay, so the request, it will be like reserved for this pod. So this is a request. So it will be like reserved for this pod by Kubernetes if the machine has enough resources, and the limit is the amount of resources to not across by the pod. Okay. So yes. So we were, yes, tell me.
Yeah, we are slightly over time. So
Yes, I'm going to finish in 5 minutes. Sorry, I'm just going to remove this namespace and then deploy it again. Okay, just to show you that using our orchestrator, so it will by increasing by doing this, it will just notice that we don't have enough resources, and it will just refuse the application, and it will not deploy it. So instead of the standard orchestrator of Kubernetes, which will deploy few pods and then remove them. For us, for using our orchestrator, you will not do this. Instead, you will just refuse the application, and then you will save time, and then you will save also energy. I'm just going to create a namespace, okay? And now I'm just going to deploy it. So as you can see, it will stay on pending. So during 300 seconds, because this is a timeout, I put it on as consonants, okay? And if after this it will not deploy, it will not be able to deploy it. It will not be deployed. So as you can see here, no solution. So we don't have any node for the pod. So we are not able to deploy this this application. So to summarize, so we compared our orchestrator to default orchestrator on small cluster of 3 machines. And we deployed like a lot of call networks on those machines, and we used like a scenario file with arrival and departure of a 5G network request. We suppose that some customers are asking to deploy some 5G networks, some specific 5G networks on our cluster, okay. And then we compared like Kubernetes scheduler and our scheduler on different scenario. And as you can see, for the acceptation ratio, like we are very close to to Kubernetes scheduler. So we are a little bit better than standard orchestrator because we are using only a small cluster of 3 machines. So this is why the difference is not very big. But for the time, for the average energy consumption, you can see that the difference is very big between the standard orchestrator of Kubernetes and our orchestrator, because the standard orchestrator of Kubernetes is wasting energy on deploying pods and then removing them, because it will figure out that it has no enough resources to deploy the whole application. So it will just deploy some pods and then remove them after this. And same thing for the average deployment time. You can see that our orchestrator, the average time of deployment of our orchestrator is slower than Kubernetes standard orchestrator, because again, this one will deploy pods, non-necessary pods, because it will remove them after figuring out that it is not possible to deploy the whole application on the cluster, while our orchestrator, it will just refuse the applications in the beginning, because it knows that it is not possible to deploy the whole application on the orchestrator, on the cluster. So we published some conferences, paper, and journals. You can find them here. So thank you for your attention, and don't hesitate to ask questions now, or just to go to the tutorial of 5G network, and also to the orchestrator. And if you have any questions, don't hesitate to send us an email, and then we will help you to use the 2 tutorials. Thank you for your attention.
Thank you, Massinissa. We will put the link to the GitHub on the page of the event, so everybody will be able to get it from there. Thank you very much.
Thank you.